Alright, so this next question is a bunch of naming and formulating, and I got a little naming and formulating review sheet right here in ionic and covalence. Ionics are here on the left, covalents are here on the right, and if you just remember, covalents are the ones that have only nonmetals only, then you're over in this area right here. Ionics always have a metal, or two polyatomic ions, or a metal and a polyatomic ion. And then these are the ones that end up having the Roman numerals and having "ide" ended if it's only two elements. And then these guys over here include things like acids, the nonmetals that have the prefixes that are on your periodic table right on the inside here called covalent prefixes. That's why they're covalent right here, also known as molecular. And then it also includes all the organic things. So these guys with metheth, prop, bute, etc. right here. So working through each one of these, I'll kind of give a reference over here. If you want to pause it and write this little sheet down, you probably have it in your notes already. Lead peroxide, so this has definitely got a metal in it, so it's Pb. Lead is +4, and then oxygen is -2 because it's in group 16 right here, and remember those are -2. Add them up to make sure that they sum to 0, so then you end up with PbO2, because you'd normally have +4 here plus -2 equals 0, and you need 2 of these to make sure that it adds up to equal 0, so PbO2. Potassium carbonate is K2CO3. Potassium is +1 because it's in group 1, and then carbonate, of course, is a periodic a polyatomic ion on the back here that's -2. Sodium nitrate, NaNO3, sodium's +1 in group 1. Nitrate, of course, is a polyatomic ion on the back that's -1. Potassium sulfide, K2S. Notice how it ends in IDE. If it ends in IDE, it means there's only 2 elements. There's a couple weird exceptions to that. Cyanide is a polyatomic ion that has more than 1 element in it that ends in "ide," but they're pretty weird. Sulfide, of course, is -2 because it's in group 16 right here, and potassium's +1. Ammonium phosphate, NH4 is ammonium, and then phosphate is PO4. Ammonium's +1 and phosphate's -3, and this is one of the weird ones where you got 2 polyatomic ions, no nonmetals, but 2 polyatomic ions that end up being an ionic compound. So polyion and polyion. Ammonium is, of course, the only polyion that we know of right now. There's a few more, but the only ones you know of right now that are that are positive. So to make these add up to 0, you got a 3 right there, so 3 of those to balance that out. And then we've got hydrochloric acid, which is HCl, HCl, sulfuric acid, H2SO4, nitrous acid. So notice it ends in us. If it ends in us, that means it came from the polyatomic ion ite. So you got to look up nitrite right here, which is NO2, and it's -1, so it goes with 1H, so HNO2. NaCl over here, sodium chloride. No Roman numeral needed because it's in group 1 or group 2. Remember, those are the only ones that do not need Roman numerals. There's a few exceptions. Zinc is +2, cadmium is +2, and silver is +1, and aluminium is +3. Makes an S because they're special on the periodic table, but other than that, they need Roman numerals. 2 nonmetals together, so carbon, and then monoxide or monoxide. HNO3 got an H to start, so it's going to be an acid. NO3 is nitrate, and since it ends in 8, it's changed it to ic, so it's called nitric acid. NO2, 2 nonmetals, so nitrogen. And then we got 2 of these, so dioxide, nitrogen dioxide. We got to have the di because there's 2 oxygens. And H4Cl, so polyatomic ion and a nonmetal, going to be an ionic compound. Name them: ammonium. Second one needs IDE. Remember, it ends in IDE if the second element is actually just by itself, so chloride. KOH, potassium, and then hydroxide. Whoops, I've missed an X, hydroxide. And then K2CO3, a one with potassium. Does not need a Roman numeral because it's in group 1. And then it's got a nonmetal polyatomic ion right here, so carbonate. And then we've got HC2H3O2, so here we've got an acid, and we've got an H with it, and then we've got a polyatomic ion. If you forgot the name of the polyatomic ion, it's over here. It's called acetate. Ends in 8, and 8 things changed to ic because you ate it and it was icky, and so we called it acetic acid. Backside. A few more. Hydroiodic acid. Since it starts with hydro, remember it always has just 2 elements in it if it's hydro and something ic. so hydroiodic. Dinitrogen, so that tells you there's 2, and then pentoxide, so pent is 5. Now if you forgot the prefixes, you can always just look them up on here. So pent means 5, and then di, of course, means 2 right here under the covalent prefixes. Methane, CH4, so it fits this pattern. C to the N, H to the 2N plus 2. If you forget what the prefix meth means, you can look right on here, organic prefix 1, so C1H2 plus 2 or 4. Octane, C8, H, now 16 plus 2 or 18. Propane, C3, H, 6 plus 2 is 8. Ethanol, now it ends in OL right here, so that means it's an alcohol, and so it fits this pattern right here. So C2, because it starts with eth, H5, because it's 2N plus 1, and then it's got an OH on the end of it, so C2H5OH. Butane, once again, ending in ANE, so it's one of these organics with the C to the N, H to the 2N plus 2, so C4H10. Carbon disulfide, so carbon S2, because it's got a di right there. So if you forgot those prefixes, remember they're over here again, these covalent prefixes for di. Hydrogen bromide, so this is just HBr. It's got to be in the gaseous form, otherwise we call it hydrobromic acid. Propane, C3H, 2 times 3 is 6, plus 2 is 8, and then propanol, so now we got an OL ending again, so C3H7OH fits this pattern right here, C to the N to the 2N plus 1 OH. You know it's an alcohol because it ends in OL. All right, a couple more over here. 1, 2, 3, 4 carbons in a row, so that is going to be the prefix but, and then it's going to have the ending ANE, butane, organic alkane right here. If you forget the prefix, look on here for 4, because it's got just C's and H's in it. P2O5, diphosphorus, and then 5 is pent, so pentoxide. So how do I know to go to these prefixes? Because it's only nonmetals, and remember 2 nonmetals gives you the prefixes right here. CH3OH, it's got an OH in it, so it's going to be an alcohol. It's got one carbon in it, so it would be meth and OL ending because it's an alcohol. HClO4, so you might get that as an acid right away, an H, but you might not know what ClO4 is, and ClO4 is on here underneath the Cl's. I'm sorry, underneath the chlorines over here. So perchlorate, ClO4 minus 1. So since it starts with a per and ends with an 8, when it's an acid, it would be called perchloric acid. Per, keep the per, end in ic now because you go from 8 to ic because he ate it in Maziki. Okay, another acid. This one's PO3, H3 at PO3. PO3, if you look on here, is the polyatomic ion phosphite, ITE. Since it ends in ite, you're going to have to go to us. So this is phosphorus acid. Phosphorus. Notice it changed to us because it was an ite. H2SO3, so SO3 is sulfite. So now you change from ite to us, so it's sulfurous acid. NO, nitrogen, just name the first one, and then you only have one oxygen, so you got to use mono, so monoxide. Looks like all of these in here are lots of these things right here, and you got to differentiate between the organics, C's and H's, the only non-metal ones, see how we got only non-metals right here, and then a bunch of acid ones in here. Now we're back here with a metal one, calcium, and then a polyatomic ion. So it's a metal and a polyatomic ion, so we just call it calcium. And then PO4 is phosphate, and it doesn't need a Roman numeral because calcium is in group 1 or group 2. HCl, you know this one is hydrochloric acid. So it's 2 things, so it's called a binary acid, and you put the prefix hydro on it and the suffix ic. So it was like HBr would be hydrobromic, it was HI would be hydroiodic. And then this one, HCl gas, this one would just be called hydrogen chloride then, because it's Or you could call it hydrogen monochloride, but since it's a gas, it's technically not supposed to be an acid. That's like a tricky, evil thing that might be a bonus question sometime in your life. C2H6, this would be ethane, because we have 2 carbons, C2H6 right here, and the prefix for that, of course, is eth, and then you put the ending ane on it. That is the naming and formula problem.